Welcome to Is454. I'm Professor Fahmi Jalani. Today we will covering cube design for lecture 3. Some of the agenda will be talking about will be what are cubes, multidimensionality, storage of multidimensional data, hierarchies, and also operation. So what are cubes? Here we have a diagram stating the three dimension, in this case of a customer and product. In terms of over time, we have profit and cost with revenue. Here is a multi-dimension representation of basically a data. We call it hypercube. And at times it could be more than 3 dimensions. Some facts about the table. It contains numerical measurement of certain business process. Example, $12 sales in New York store on December 1st, 2008, for example. Additionally, foreign key to design dimension table. Example, further store sales person's information. And it's the center in a stars scheme. For the dimension table, it contains attributes by which data can be grouped. For example, a city, region of store, product category. The next point, linked to the fact table by the primary keys. Fourth is slow changing dimensional dimension with change over time. This can be dealt with 3 ways. Either overwriting the old values, add new rows to table, distinguish a record by version, and last but not least, add new attributes to existing growth. For data storage model, we have first one is relational database, or ROLAP. Some example will be data in database, in tables, for example. Some stores in pre-calculated tables could be summarized. Next, we have a multi-dimensional database, MOLP, or data in multi-dimensional arrays. It requires less disk space, and hence we give better performance. This is pre-calculated aggregates. Timeout aggregates and calculate and updates require recalculation, or we have hybrid, a bit of both. Next, we have hierarchies, which are a group of dimension. This case example is months, semester, quarter, or year. For example, in 2008, it could be quarter 1, semester 1, for example. With quarter 2008, it consists of months from January to March, followed by quarter 2, 2008. Okay. Another example you can give is country, sales region, state, city, and store. In this case, for example, Germany, South Germany location, Bowie, Stuttgart, store A and store B. Okay, followed by another area after southern Germany could be Bavaria, okay, and so on. Munich and store ABC, for example. Let's take a look at operational. This is slice. The diagram shows quite clearly slicing is the process of retrieving a block of data from a cube by filtering in one dimension. So by slicing the original cube, you get a slice of the piece. Alternatively, we have dice. This dicing the process of retrieving a block of data from a cube by filtering all dimension. This is basically a segment or a large chunk of the dimension where it's been retrieved. Next, we have operation drill up and down. Drilling up, presenting data at a higher level on the hierarchy. This could be from store to all the way up to region, okay? Or reversing, the other way around, ascend or descending, presenting data at a lower level to the hierarchy, okay? From region to store, example. Okay? Just refer to the diagram below. So in building a cube in SSAS, a few things to take note. The precondition, which consists of connecting the data source. Okay, it could be a library source, it could be a banking source, financial source, HR source. Okay, defining views, what the output you want to see by massaging the data. Selecting dimension, could be 3-dimension, multi-dimension, or hybrid, or 1-dimension. Define the fact and dimension tables and time dimension. Also, you have to select the measures, yeah? For example, the time period, and deploy, and query the queue, which is execution of the queue. Okay, so that's pretty much it for lecture 3. If you have any question, please feel free to email me or drop by my office for appointment. Thank you very much, and please stay safe. Bye bye.